What's up, guys? And today I'm going to talk about web page performance. This is my simple landing page, and this page has simple buttons. Drop-down elements, and they created with JS, filter, search. We can, for example, find Canandaigua, New York. And this site is deployed with GitHub pages. And a lot of people don't know how to measure web page performance. So as usual, web page performance consists of network speed and load time, and oh no, what is it? Oh, and load time and web page user experience. I mean accessibility. How much time it opens, fast or slow. No, it's broken. And how to measure it. So in DevTools, we have a performance monitor, and we can find that CPU usage is low, and we can improve it by many ways. And how to improve our CPU performance? We can add 6 times slowdown and go to performance monitor. And we can notice that our CPU usage is increased to 20%, but 20% is okay. It's good. Oh no, 44. And also we can find JS heap size. Heap size, it's a size of JS objects which stores in our web page virtual machine. How to enable performance monitor? We can go to DevTools options, and we can possibly find Lighthouse, security applications, more tools, and we can find performance monitor, rendering, layers, and so on. So also we have a Lighthouse. Lighthouse is a tool. It's good enough when we should test performance, accessibility, best practices, SEO, progressive web apps. For example, we can analyze this page. And we can find that our performance isn't good and our SEO isn't good. And we can proceed to performance, open it, and find that we have the LS as bigger. And Google advises us how to get rid of these large layout shifts. We can improve this. We can also minify JS with Terser in Webpack 5, minify CSS, serve images in WebP or AVIF format, and do another things to improve our performance. And also this performance is good enough. And we can slow network, for example, fast2G, and measure how it's slowed. Uh, 8 seconds is good enough. Also, we can 16 seconds. 16 seconds with fast2G. We can improve it with next-gen format. The most important thing in network by size, uh, it's our it's our oh no, where it is. By size, it's our page, our images. So we can reduce size, we can squish it, and it will get rid of additional kilobytes. How we can proceed? But the most important thing when we measure accessibility, when we try to interact with our web page, we can notice that it's good. We don't have layouts. We can notice that we don't have a lot of style recalculations per second. And our JS heap size is less than 10 gigabytes. So we can measure our performance with record. We can record our interaction with web page, and after that we can analyze it. So for example, we can do something like this. Press buttons, unpress buttons, open drop down, go to contact us, stop it. And we have a summary, and almost all the time is IDLE and the system. So we can find a call tree, can sort it by milliseconds. It's our timer, it's recalculate style, it's event mouse over, function call, and we can find what function call it. If this function is too slow, we can optimize it, but it's okay. It's okay, it's pretty okay because it's less than 50, 60 milliseconds. And this site is good enough. Because they don't has this web page don't has a lot of recalculations and so on. Also, we can go to this and find the interactions, animations, how much time it takes, and which type of animation. Also, we can find the main thread compositor and thread pool for ground worker. And we don't have we have a rasterized paint in thread pool for ground worker. If we go to interactions, and we can do something like this, and we can find that is a pointer, event, pointer, and it takes 30 milliseconds in average. And we can inspect any interactions, any animations. It's simple, we just open a small region and can inspect pointers. What is it? This one. And go to this summary, and we can find that it's a paint, it's a commit, activity recalculate style, valorize, and prepaint. And we can inspect our web page processes while we measure our interactions with web page. So, and for example, we can go to bad websites, complicated, heavy. For example, Mississippi is a bad website, but looks good. But because only of reloaded state, if we go to network in our DevTools, push the button disable cache and reload this page, we can actually find that it loads too long. They load a lot of fonts, JPEG with huge size. They load a big library, widget.js. It takes 1.1 MB. And the full loading of site is bigger than 40 seconds. Yeah, it's bigger than 40 seconds. For example, we can go to Lighthouse and also analyze page load. Also, we can notice small tips from Lighthouse. By reducing the average user device costs less than 200 USD. 70% of mobile pages take nearly 7 seconds for the visual content browser. Is the number? Oh, too fast. Lighthouse is gathering information about the page to compute your score. And I guess it should be really bad. Really bad Lighthouse. Almost there. Lighthouse is also slow. They has a slow performance, slow accessibility, slow SEO, but they have best practices. They has a very low speed index because they load a huge bundle and it's not chunked by small chunks. Speed index is slow. We can also view tree map, and we can find the most biggest unused bytes all. They have a lot of mistakes. They should reduce initial server response time, eliminate render blocking resources, LCP, reduce unused GIS, serve images in next-gen formats. But they have a good accessibility mark, also frame and iframe, buttons do not have an accessible name, links do not have a discernible name. And we can also go to performance monitor And we can find that GS heap size is about less than 20 megabytes, and CPU usage is sometimes up to 60 or 80%. So yes, site is heavy. And if we go to performance and slow down our CPU 6 times and go to performance monitor, we can find that our CPU sometimes dead, sometimes alive, but I have not a cheap CPU and it's not good enough for this site. They have a 3000 DOM nodes, 240, 260 GS event listener, and when we scroll, they should they've they have a lot of style recalculations, change layout. We can find that these numbers are changed. And I should say that yes, we can measure how much approximately how much GS takes memory by performance monitor. It's approximately, it's not has a good accuracy, 100% good accuracy, but we can rely on this to measure, for example, this site and this site. And this site is much better. Much worse. Much worse. And for example, we go to award and press F12 for DevTools. We can find that they have 12,000 DOM nodes, less GS7 listeners, but they have style recalculations. They have a lot of style recalculations, but we don't change anything. We just move our pointer, our mouse pointer from left to right, up, down, and when we scroll, it also increased. But they haven't layouts change, only style recalculations. Maybe it's because they have a lot of DOM nodes, and JS heap size is less than Mississippi site, and CPU usage is also less than Mississippi. It should be quite better. So for example, we can go to Lighthouse and analyze page load. Also should say that it can takes a lot of time. It can takes because Lighthouse speed depends on the speed on the website, and if the website is slow, Lighthouse also slow. Also should say that we can choose device. If we build a mobile website, we should change this checkbox to mobile to measure Lighthouse for mobile, but performance, it's common for mobile and for desktop. JS is pretty similar, but also this has a smaller performance rate by Lighthouse, but in performance monitor we can't mention that this has less performance, but sometimes it's up to 30, maybe 50%. For example, let's slow down our CPU. And when we scroll up or scroll down, it's up to 70%, but not go to, but no, sometimes it go to 94, 93%. It's also a huge and complicated site, and we can measure, we can go to Lighthouse results. And what is web performance bad in this? They have a bad first contentful paint, bad largest contentful paint. They have a big speed index, but less than Mississippi. And we can proceed to view tree map. And for example, we can find the most huge resources in this site is, for example, Chrome extension, Google Tag Manager, UI Loaders JS Core, Chrome extension. We can go to this and find unused bytes. Pages content script start.js, UI Loaders JS Core. And we can find, if we remove these libraries or change them, we can reduce bundle size and its influence to our web page speed. Bad influence. We can remove this and increase good influence. User time and marks, accessibility, but they have a good best practices and bad SEO. It's also not progressive web applications. Also, we can do something like we do in the previous. Let's slow down our CPU and measure it. Just scrolling. No open something, just scrolling. Just scrolling. Left to right, right to left, and stop it. And we can found that if in the previous measurement we have about 95% of all of the time it was IDLE, and in this side it only 50% of IDLE, and it's bad because we should not high load our CPU. So let's find what the most heavy tasks. It's rendering, scripting, and system, but system we can't change, and the painting. So go to call tree, and we can proceed that 1.3, 1.2 seconds. Its activity of timer fired. From E, it's set timeout in this function. Also, we can proceed to this function call, this function call, this function call, and CSS, access, anonymous style. It's from jQuery, and because of jQuery, it's a really slow site. And we can find that recalculation style, it's only because of jQuery, and we can proceed to this code and find that our jQuery try to change offset width from a element. It should be a DOM node, I guess. And let's return. And we can find the heavy functions from jQuery, change it to CommonJS or another library that not too heavy, and increase speed of our web page. So let's do something like we do before. Let's give network, layout, and main. And we can notice that our main is really huge. Compositor, thread pool, GPU. So for example, it's just a scrolling from this to this. And in main, we can find the timer, function call, anonymous function, on scroll function, load images, each function, tasks, commit, event scroll, access, anonymous. It's really huge load to web page because our this web page increased a lot of events just for scrolling. And this in the right side of this record, I move from left to right, and for this we can find it violet color increased from the left side. You can find that it's a hit test. I don't know what is it, but I don't think it's good because just for left to right, they increase layout hit test. So let's search. What is it? Hit testing is a process of determining whether user controlled cursor. So this side control our cursor when we move it to left or to right and save it data to maybe to local storage, I don't know. But they spy on our cursor pointer in this side. And in conclusion, we researched three sites, good and too bad. And I should say that our website not perfect, but we should try to make it better, to provide a better interaction experience with our web pages to our users, and happy users may pay more attention to our sites, and often more often come in to our sites, and that's the end. And yes, I should say I hope it was useful for someone, and I hope web developers change their principles in the way to provide better user experience. So thanks for watching.